most of all, we're going to find out if we can actually really get away from this, heat-seeking missile. Later on, in chapter 10 or chapter 11, we are going to upgrade our discussion to also include this. Okay, and why, when dealing with the equations of motion, this is different to this, and when is it different? So, just something to look forward to. Now, nope, go back. Yeah, here we go. Okay. Now, we discussed gravity, we discussed the direction of gravity, and we discussed this. Okay, we discussed what happens when we are going at an angle, and then we discussed the package that when it's dropping from an airplane, what are the initial velocities. Now I want you to think of everything we have done so far, and we are going to actually start this lecture with a combination of a PIQ problem / revision of what we did in the previous lecture before moving on. So in your Moodle, you will see PIQ number 8, section 4.4. You will see 3 this time, 4.4, 4.5, 4.6. So we're going to use 4.4 now. And the results, the question so if you log in, okay, this is the question. Package A.
4.5, Doctor?
4.4. And Moodle just decided to close in my face. Sorry. We'll start again. Not a good start. Okay. Refresh the page if you can't see it. The question should now be on your screen. And it says, package A is dropped from a plane moving east at constant velocity. Now, in the previous PIQ, in the end of the last lecture, we said that when something is dropped, it has the same initial and velocity in the x and y axis as the plane that is dropped from. Now, this time it says from the same height at the same time, package B is dropped from rest from a stationary helicopter, so not moving. Ignoring air friction, which one is correct? And you have 5 options. So this is the first question. So I'll give you about 2.5 minutes. Okay. Let's see how we fared. About 100 people answered the question. 80 of you chose option B. About 15 of you chose option E. And 5 people chose the other options. And I'm really happy with this result. The correct answer is indeed option B. Now remember that the time it takes for something to fall is all to do with the y-axis, nothing to do with the x-axis. So since object A falls like this and object B falls like this, amazingly, they still reach at the same time because the vertical distance, this distance, is the same for both of them, irrespective of the fact that A goes to the right. Okay, I'm really happy to see these. I'm really happy to see this.
Doctor?
Yeah.
What if we consider air friction? What would be the answer?
It would still be the same if they have the same. If it's the same package, okay, same dimension, same mass, okay, it would still be the same. They would still reach at the same time because the vertical distance is still the same. Okay, the only time, okay, it makes a difference is if with air resistance is if they have different profiles or different masses or different shapes, like the video we saw with the feather and the ball. Yeah? Okay, now the next question is...
Doctor,
Aywa?
if we get the component for the velocity in these two cases, we find that the Vy is equal 0. V naught y.
V naught y for both of them will be equal to 0.
Whether it's from the rest or drop.
Dropped means from rest.
Okay.
Okay. So dropped and dropped from rest is they're both dropped from rest. Okay. Maybe the question was not clear. I'm sorry about that. So the opposite of dropped is to drop something is to throw something. Now that would be different. If one of them said dropped and the other one said throw or threw, now that would be very different because then the V naught would be different. With dropped, V naught y would be 0, but V naught with throw would actually be a number. It would not be 0.
Okay.
Okay.
No.
So your colleague was asking, this says dropped from rest. Would it be any different if it said throw؟ يعني إذا رمينا الباكج بدل ما أننا نتركه. في فرق ما بين إنك تكون ماسك شيء في يدك وتفتح يدك وما بين إنك one second. I want to get my video cam on because it's just not possible to do some stuff without.
دكتور
أيوة.
يعني الفرق انك لما يكون دروب بيكون تسارع من نفسه الجسم ولكن اذا رميته بيكون انت اعطيته تسارع.
There we go. Okay, I managed to get my back cam on at least, not the front one, but the back one. Okay. Here. If I say drop, this is what I do. I have something in my hand. I simply open my hand and it drops to the floor. Okay, so my initial velocity is 0. As soon as I leave it, it starts accelerating downwards. If, however, I say throw, then I'm not just doing this. No, I am actually throwing it to the ground. So I'm giving it an initial velocity in the y-axis. واضح الفرق؟
Yes.
Okay. Now the next question might sound even sillier than this one, but it's a fun question to think about. Suppose you're driving a convertible car على أساس إننا نحن ما في عمان وما بننشوي with the top roof open. Your brother sitting at the back seat throws a ball up. In the absence of air resistance, if we don't have any air resistance, where does the ball land? Does it land behind the car, in front of the car, or back inside the car? Okay, your brother throws the ball vertically upwards without any X component due to the throw itself.
Ahead of the car.
Back inside car.
Okay, so I have put the PIQ up on Moodle. Okay, this is very, very simple question, so I'll give you just 1 minute for it. Someone said behind, someone said ahead. I see a few people are voting back inside the car, so I'm really interested to see what the result of this vote would be. Okay, about 80 people have responded so far. Okay, so 87 people said back inside the car. 4 people said ahead of the car. And 11 people said behind the car. Very, very interesting. Okay. Now, most people said back inside the car. And I must say, these people are actually correct. Now, think of it. Once the car is moving, now you're about to witness another one of my really amazing drawings. Okay. And it's such an amazing car. Here, see, it's a Mercedes-Benz. Okay. All right. So if the car is going in this direction and your brother throws the ball up. Now, the key point is your brother throws the ball up, so he gives it a Vy, right? But since the car is already moving in the X direction, okay, that means the ball also implicitly has the same velocity since the ball is already inside the car and your brother is also inside the car. Okay, someone has a very good valid point. وين الكشف هو نص السيارة طارت. زين كذاك؟
Doctor, I have a question, please.
أيوة.
But since the car have tires, right? So the tires is keeping the velocity of the car, correct?
Mm-hmm.
But when he when the brother throw the ball upward, this ball, yeah, it has the same velocity of the car, but there's nothing that keep pushing it toward the direction which car moving on, correct?
You are correct. There is nothing that keeps pushing it in that direction, but also there's nothing taking away that initial velocity. It's the exact same idea لما قلنا something is dropping out of the airplane, صح? Now, when it was inside the airplane engine was moving the airplane at VP of the airplane. So when we threw the package, it was moving in the east direction at VP, صح?
أيوه.
Lakin once it's out of the plane, there's no engine anymore. So why does it keep going east?
Because of the velocity of the airplane, correct?
But now we threw it out of the airplane. هي كانت أول شيء هذه ما أعرف إيش الطيارة الخرندعية. زين. هي كانت أول شيء على VP، صحيح؟
أيوه.
لما كانت داخل الطيارة. طيب لما عقيناها من الطيارة، طيب قلنا أنه عندها VP وأيضا V in the Y axis، صحيح؟
أيوه.
اللي هي V نوت Y كانت 0 بعدين تزيد لأنه في acceleration G.
أيوه صح.
إنزين. طيب لكن بما أنها هي already الحين برا على الطيارة، ليش هذا ال VP بعدها موجودة؟ الإنجن ما موجود.
هي لأنها كانت داخل السيارة، صح؟ قصدي داخل الطائرة، فالطائرة عطتها السرعة اللي
بالضبط. نفس الفكرة هنا، هي كانت داخل السيارة فالسيارة عطتها السرعة VC. لما انت عقيتها برا على السرعة VC هذه ما تختفي، تظلها موجودة معها.
يعني إذا ما اعتبرنا الهواء ما في شيء ثاني، يعني
إذا ما اعتبرنا الهواء ما في شيء ثاني يوقفها. أيوة، إذا اعتبرنا الهواء أول ما الكرة تطلع من السيارة إيش يجي؟ بيجي هواء من هذه الناحية وبيعطيها ريزيستنس وبيوقف الكرة. فالسيارة بتظلها تمشي قدام والكرة بتوقف مكانها وبتطيح ورا السيارة.
أيوة فهمت.
زين. هذا إن شاء الله في الشابتر القادم، شابتر 5، راح نتكلم عن هذا الشيء. إنزين، من منطلق القوة، إنزين شو اسمه الفورسز، وراح نتعرف على قانون نيوتن الأول اللي هو كل شيء في الحياة تمبل. قانون نيوتن الأول اللي هو كل شيء في الحياة تمبل. إنزين، فراح هذا إن شاء الله بداية الليكتشر القادم نتكلم في الموضوع.
Victor, I have a question.
Yes.
Like if instead of the car we have a big spinner.
Big what?
A big spinner.
Spinner, okay.
Would anything change?
So you're talking about something that is going in a circle وعندك شيء فيه وبعدين رميته، إيش يصير؟
Yes.
Yes, something will change, and we will actually speak about this a little bit in about 10 slides time. Okay, here it will not keep going in a circle, it will go in a straight line.
Velocity direction change.
We will explain why that is in about 10 slides time. Okay, so if we have something launched with an initial velocity V naught, and anyone here who has ever kicked a ball or played football can confirm or deny this. If I kick a ball at an angle, this is what the trajectory of the ball will look like. Is that correct?
Yeah.
Yes.
Yes.
Okay. So let's draw an X and Y axis. Okay. This is a vector, so I can break it down into V naught X and V naught Y. صحيح؟ V cosine theta, V sine theta. Yes?
Yes.
Okay.
Yeah.
All right. Now I will do something. I will write all of these equations 2 times. But you will notice something. In one of the 2 times, I only have the x-axis. And in one of the 2 times, I only have the y-axis. It's like we discussed in the previous lecture. It's a property of mathematics that in an orthonormal set, a coordinate set, the two axes don't speak to each other, صح? We discussed about this. الحين بما أنه الإكس والواي أكسس زعلانين ما يتكلموا مع بعضهم البعض، هذا الشيء في مصلحتنا. Think of it this way. Let me see who is on. I'll pick random names from the names in front of me. I don't mean anyone actually owes me money, okay? But I always find that money is a good example because people wake up. Okay, let's see. I will choose 3 people. Ma'athar, Mubarak, and Hassan. Ma'athar owes me 10 riyals. Mubarak owes me 5 riyals. And Hassan owes me 2 riyals. Now, when I come to do the calculation, I can do it all in one step. The amount of money that I am owed is minus 10, minus 5, minus 2. That is minus 17. Now, if Mubarak gives me 3 riyals back out of the 5, that is minus 17 plus 3. So now I have minus 14 riyals left. But who gave me what? Okay, wait. Ma'athar still owes me 10, but now Mubarak also owes me minus 2, and Hassan owes me still 2 riyals. What's the problem with this calculation?
Complicated?
It is complicated, and it can be simplified. Okay, it can be simplified. Now, the fact is that what Ma'athar owes me, what Mubarak owes me, and what Hassan owes me, okay, are independent of each other. They're not related to each other. Sahih? So whether Ma'athar pays me or not, it doesn't affect the balance of Mubarak and Hassan. When Mubarak paid me the 3 riyals, it does not affect the balance of Ma'athar and Hassan. Okay? فليش أعقد المسألة وأحطها كلها في سطر واحد كأنه it's one complicated problem. لا, it is much easier for me to have 3 separate pages or 3 separate sentences. Ma'athar owes 10, Mubarak owes 5, Hassan owes 3, Hassan owes 2. Okay, Mubarak paid 3, فنان. 5 minus 3 equals 2. الاثنين الثانيين ما لمستهم, they are still 10 or 2. أي واحد فيهم أسهل؟ المثال الأول ولا المثال الثاني؟
الثاني.
ممتاز. I do this exact same thing في البروجكتايل في الإكس والآي أكسس. الإكس والواي أكسس. طيب بما أنه هذا الأكسيس independent وما يكلمون بعضهم البعض، بدل ما أحاول أسوي المسألة كلها in one go، أنا راح أفصل الإكس أكسس عن الواي أكسس وراح أسوي كل واحد فيهم وحده. الحين إيش الأكسلريشن في الإكس أكسس؟ ما عندنا إير ريزيستنس. إيش الأكسلريشن؟
0.
0. معناته I can simplify. If my acceleration is 0, my v final equals my v initial. جميل.
Yes.
In the y-axis, my acceleration is g minus 9.8 meters per second square. So I can rewrite my equations this way. Right? Now I will beg you to do something. Do not memorize these equations. You only ever need to remember these. Even these 3 equations في المربع will be given to you in the test. You just need to know how to understand them. Okay? So do not memorize this. Okay? It's all about application. Look, I took the exact same equation, حطيت في x, حطيت في y, سويت application, I got a whole bunch of new equations. If we try to memorize every single one of these, we end up with a nightmare. Okay. Now we have some cheating equations as well, and I will teach you.
Doctor,
Aywa?
Doctor, in the previous slide, can you just go back to the previous slide?
Yeah.
Why why the sign of the first, the first equation is about y is positive, and the second thing is minus. Because of the g? Because, yeah, I mean the sign, yes. Here, there's positive and here is the minus. We already know that.
The equation itself is v equals u plus at. A in this case is minus g. So what happened is we did this, v equals u plus at, وبعدين سوينا substitution بهذه الطريقة. and we ended up with this.
So if we write the value of G, we write it like minus 9.8 or just 9.8?
No, here if I substitute now I just put 9.8 لأنه already حطيت الماينس من قبل.
Okay. So that's the reason. Okay.
لذلك قلت لكم لا do not memorize these equations because it will be confusing. If you just use the basic equation and you substitute the numbers, you will always be safe. Okay. Now here is a cheating equation. R equals V naught squared over G sine 2 theta. And this gives me the range, okay, the horizontal range. So it tells me if I kick a ball, okay, or I launch as a nuba from ground level with velocity v naught at angle theta, it tells me it will land at this point and this distance will be r. Now here's a key point, and many students make this mistake. There is a very basic rule with this equation, and it only works at one point. Okay, it only works in specific cases. Namely, okay, you need to start and finish at the same level. Okay, here's a question. If I start from here and I throw something on top of a wall, can I use that equation?
No.
No, they are on different levels. What it will give me is it will not give me this, it will give me this distance. So it will give me an extra amount d. Okay, what about this? I am throwing something inside a pool. Can I do the calculation here?
No.
No. What it will do here is it will give it to me at the same level, so it will give it to me here. It will rob me of this distance. Okay, what if I throw something من أعلى جدار إلى أعلى جدار ثاني?
It can be.
It could be.
This can be because they are on the same level.
Yeah.
This is very important. Okay. Excellent. Okay. So we'll do one more question and then we'll go to do a numerical example. And I will give you, okay, what I'll do is I will put you in breakout rooms for about 4 minutes, okay, to do this question. Discuss it amongst themselves. I will give you a hint. It is not as simple as it looks. Okay, so I'll give you time. I'll give you about 4 minutes to do it. I'll mute myself and I will go to drink a glass of water and come back. By the time, hopefully 4 minutes, you would be done. Okay. So I see there's quite a few discussions that have happened. I'll wait until everyone is back into the main room. Okay, so let's see. Seems that there were quite a few discussions happening on, and the results are quite interesting. So I'll show you the results. So very interesting. 40 students did not answer. And out of the 68 students who did answer, okay, we had almost an equal number of students choosing each option, which is very, very interesting. Okay. So Salha throws ball A, Mariam throws ball B. Which ball hits the ground first?
A.
Ball A, ball B.
B.
Now, here is something. The time it takes for the ball to hit the ground has nothing to do with the x-axis and all to do with the y-axis. صحيح?
Yes.
Yes.
So if we throw the ball at this some angle theta with some v naught, okay, it will have an x component and a y component. Now, depending on how much the y component is, it will take certain time x to go up and another time x to come down. So 2x, so 2t. T to go up and t to come down. Okay?
Yes.
Okay. But also, okay. So can we tell just from the photo which one of them, A or B, will take more time to come to the top? This gives us distance. It doesn't particularly give us time though, does it?
Yes. No.
It doesn't really tell us what the velocity is.
No.
Yes.
Yeah? I mean, I can have something go at 10,000 meters per second and launch it at a trajectory that goes like this. On the other hand, I can have something only going 100 meters per second, but launch it at a trajectory that goes like this. So turns out, and that is why I told you this question is actually trickier than you would think. Okay, the correct answer is that we need more information. The amount of information I have given you is not enough to answer this question. Okay. And if you remember what I said at the end of the previous lecture when we spoke a little bit about learning, how to learn, the job market, etc., this is something that you find in life a lot. Okay, especially later on when you go to the job market. Or who here has heard of the term big data? Can anyone here tell me what does big data mean? No? So big data refers to the fact that in today's information and age, we are collecting so much new information every single hour and every single day and every single second, okay, that it is impossible for a human brain to go through all of them. So there are now companies that are developing artificial intelligence systems just to sift through this data. But that also tells us what this question teaches us is something else that is quite important. ليس كل ما يلمع ذهبا. Okay, many times you will have loads of information. It just turns out that information is not enough for you to make a decision. That information is garbage. Okay, and we shouldn't be afraid. Okay, we shouldn't be afraid to. We shouldn't be afraid to. What's it called? To say that we need more information. There is no problem with that. Okay. Okay, give me a second. I need to end this session because this is the end of the session. And we will move on to do a numerical example for all. Okay, seems to be that we have some sort of issue with the system. Let me see. Give me a minute. Okay, moving on. Does anyone want to tell me anything before we move on? Hint, there is something that you should be telling me before we move on.
Mr. Please, I have a question.
Yes, tell me.
You said we depend on the y-axis, right?
Mm-hmm.
When we look to the picture, B is smaller than A, so the answer will be B.
Okay, are you absolutely sure about what you just said?
Maybe.
Okay, how sure are you from 0 to 100?
I don't know, I don't get it so clear.
Just give me a number. From 0 to 100, where 0 I am not sure at all, and 100 I am absolutely sure. How sure are you of this?
15 maybe.
15, 1-5. Okay. And yet you chose to speak up and tell me that what the explanation I just gave and said need more information is wrong. Yes?
Okay.
Okay. I have a piece of information for you.
Doctor,
Aywa?
when we get the y component for the velocity, we depend for the cosine. Yes?
Okay, sine or cosine, depending on which angle you take, but keep going.
Well, yeah. دكتور يعني في الزاوية في البي لما تقل بتزيد سرعة الفيلوسيتي. وعشان كذا اخترت البي لأن الزاوية أقل.
Okay, so we have two people now telling me that I gave you a wrong explanation, Athir and Musa.
Doctor, can I comment about that?
Yeah.
You told us يعني احنا لازم نتبع على الواي صح؟
أيوة.
لو شفنا المسافة اللي قطعتها يعني ال A في الواي أطول من ال B صح؟ العلاقة بين المسافة والزمن عكسية. inverse relationship صح؟
Yep.
دائما ال A قطعت مسافة أكثر. Oh no, that's wrong.
لا ما inverse, it's a straight relationship. More distance, more time.
Yes, I mean this. So A قطعت مسافة أكثر صح؟
أيوة.
فزمنها بياخذ أكثر. والبي قطعت أقل لأن في الواي خذت قيمة أقل، فمفروض التي تكون معها أقل. الإجابة بي، يعني معنا information كافية.
I really wish my webcam was working today, because the 3 or the 4 of you have no idea how much I am smiling at the moment. 2 minutes ago, I told you about something called big data. Okay, and I told you that we have a lot of information and that it is very difficult to sift good information from bad information. And that is one of the key points that we do. And that will be one of your key responsibilities, inshallah, in the job market after you graduate. And guess what? You are correct. So, Athir, Musa, Zahra, one more person who spoke.
I'm smiling now.
Okay. Sorry, Zahra. Okay.
I said I'm smiling now.
Sorry?
I said I'm smiling now.
Yeah, I am smiling too, because you are absolutely correct. Everything I just said was absolutely garbage about needing more information. What I told you about big data is correct. What I told you about looking at the sine and cosine is correct. But need more information was garbage. The correct answer is indeed B. Okay. Now, quite a few of you, okay, had that idea in your head, in your brain. طيب لكن أنت you told us أنه we are looking at the y-axis alone. إنزين. طيب هنا y-axis أكثر وهنا y-axis أقل. معناته البي يوصل أول. أنت قبل شوية جالس تتبربر وتقول أنه don't take the x-axis into consideration, or the x-axis when we are ignoring air resistance that might make a big difference. والحين جاي تقلب كلامك. You are absolutely correct. The correct answer is actually B, and not need more information. So I did this on purpose. Okay. I did this on purpose. Okay. For 2 reasons. واحد أشوف من نايم من قايم. Okay. Second, to teach you something very, very important. Just because. So, Asam. Okay. Pause. The correct answer is B. Okay. B is the correct answer because it goes through less distance. So y of B is less than y of A, distance. Okay. So since B has less distance in the y-axis, it needs less time. So it will reach first. Okay. All right. الحين كان في سبب صح انه ضيعت 2 3 من المحاضرة، بس استحملوني لانه في شيء مهم جدا. ما لانني انا دكتور او لانني انا في موقع المعلم دائما كل اللي اقوله راح يكون صحيح. اوكي. انا تراني انسان، والناس اللي في موقع السلطة والناس اللي هو في موقع بكرة ممكن يكون مديري في الشغل، ممكن يكون وكيلي، ممكن يكون وزيري في العمل. طيب ترى كلنا بشر وكلنا معرضين للخطأ، وهذا شيء جدا مهم. إنزين. If you really believe in something, and if you really believe in something and believe that based on the information you have, this is the correct answer, or this is the correct approach. Just because someone who is in a position of power tells you this is incorrect, okay, that does not mean that that person is right. You might still be right. Okay, this is a very important. This is a very important thing. Okay, but also be careful with something. هذا ما مفروض يأخذنا للغرور أنه دائما أعاند وأقول لا أنا فقط الصحيح. كيف ما الثانيين ممكن يغلطوا أنا أيضا ممكن أكون غلط. ف we always, and this is the scientific method, this is how we deal in science. We take action, we take decisions based on, okay, based on information, okay, not based on only opinions. Okay, now you had solid information from the previous lecture and the first half of this lecture that only the y-axis matters. So it doesn't matter what I say. يا اما تقول لي انه اللي انت قلته قبل شويه غلط يا اما انت جوابك غلط. Ruqayya, since there is no air resistance, the mass doesn't make a difference. Remember that video of the feather and the ball in vacuum when they reached exactly at the same time?
Yes.
It's exactly the same thing. Since there is no air resistance, okay, we don't need mass. If we take air resistance, then we need to take mass into consideration. طيب. Let's move on and do a numerical example. A ball is kicked with an initial velocity of 30 meters per second at an angle 53 degrees with the horizontal. This is what it's going to look like. What's the first thing I should do?
Find the component for the velocity.
Okay, that's the second thing I should be doing. But what's the first thing I should be doing?
Write the
Something that
equation.
we always need to do.
Write down your facts.
Write down and draw. Okay, first always draw the problem. Okay, now I'm drawing a lot of details here because this is PowerPoint. If I was doing it on a piece of paper, I probably wouldn't draw any of this. Okay, so I draw the x and y axis, I draw my ball, I draw the angle 53 degrees, I draw my initial vector v naught. I write down I am starting at t naught equals 0, at x naught equals 0, y naught equals 0. My initial velocity v naught is 30 meters per second. So I need to bring in the components. V naught cosine 53 for Vx, Vy is V sine 53. And I write all of this. And I'm actually going to go one step further and I'm going to do this. Can someone tell me what is 30 sine 53? Should be about 24 meters per second. And 30 cosine 53 should be about 18 meters per second. هل في اعتراض على أي شيء قلته حتى الآن؟
So we multiply by cosine the angle to find the velocity in the x direction and sine for the velocity in the y direction?
Yes, because in this case we have this angle.
Okay.
Since we have this angle, the y would be opposite and the x would be adjacent.
Okay.
Okay, now I have all the information to start doing the problem. Question A. Find its position and velocity after 1.5 seconds. So we needed at t equals 1.5 seconds. What is Vx? What is Vy? What is distance? Well, it's not as difficult as it looks. Okay, we have our equations. V equals u plus at. First thing first, what is V final will be in the x-axis?
0.
0 in the x-axis?
Same, 18.
Same.
The same.
We don't have air resistance, صح?
Well,
So my
then
final velocity will be the same as my initial velocity.
Yes.
Okay, what will my final velocity in the y-axis be?
0.
0.
Why 0?
Gravity.
Because to reach the maximum.
Because the
same.
maximum.
No, doctor, we calculated.
We need to calculate it. Yeah. We do
By
not
the-
know if at t 1.5 it is at the maximum point. Yes, if we know it is the maximum point, then we can say it is 0. But we don't know it is the maximum point, so we need to calculate it. Let's find out. Vy equals initial Vy naught was 24 plus minus 9.8 times 1.5 seconds, and this will give me 9.3 meters per second? Yes?
Yes.
So my V final Y will be 9.3 meters per second. What about distance? How can I find the X distance and the Y distance?
X distance by V1X plus multiply T.
Okay. So I do 18 times 1.5, which is 27 meters. And Y, what do I need to do for Y? I have my equation S equals UT plus half AT squared, صح?
Yes.
So my initial is 24, my time is 1.5 plus half minus 9.8, 1.5 squared. And that should give me 24.75 meters. So my final velocity is this. Not my final velocity. My velocity at 1.5 seconds is this, and my distances at 1.5 seconds is this. Next part of the question. Find the maximum. Aywa.
If we want the speed, we find the magnitude for the 18 and 9.3.
Yes, if we want the speed, we find the magnitude. Yeah. So if the question asked for the speed instead of the velocity, did it look for speed or velocity? The question asked for velocity. If it had actually asked for speed, then speed would be 18 squared plus 9.3 squared, all square rooted, and it will be 20.26 meters per second. I'll just write it as 20.3. This is speed. Velocity. Speed. Excellent question. So part B asks us, find the maximum height it reaches. I want to know what is the maximum height. How do I do this? Which equation should I use and how?
Is when Vy equals 0.
Yeah, that's a good option. When Vy is equal to 0. Okay, so we know V equals U plus AT, S equals UT plus half AT squared, and V squared equals U squared plus 2AS. Which equation should I use?
Last one.
The last one. So my final velocity is 0. My initial velocity is, what was it? 18? 24? 24. 24 squared plus 2. My acceleration is minus 9.8, and there's distance. And if I rearrange, I will get my distance to be 29.4 meters. Everyone got the same answer?
Yes.
Yes.
Yes, Mr.
Good. And you will notice that this is actually wrong because this should be 29.4 meters. Okay. Part C. How far away will it reach the ground? I can do this question in two ways. Can you tell me how?
R.
Okay, R is one option.
We get the time when it reach the top and multiply by 2.
Excellent. Perfect. So these are two ways. So now I'm going to cheat and I'm going to use the range equation because it's just easier for me. Okay, I will put R equals V naught squared over. Can someone remind me of the equation?
G sine 2 theta.
I went too far. Okay, V naught squared over G sine
2 theta.
2 theta.
Yes.
So V naught squared would be 30 squared على 9.8 sine 2 times 53 degrees, which is equal to 9 meters.
دكتور
ايوه،
ليش ما خذيناها بالسالب؟
وين في السالب اخذناه؟
9.8 الاكسلريشن
في السؤال اللي قبله؟
لا في القانون هذا تحت هذه.
ليش قسمته على 9.8 ما سالب 9.8؟
ايوه
ما فهمت السؤال.
دكتور
ايوه
قصده
ليش
في
قسمت على 9.8 ليش ما سالب 9.8؟
إذا قسموا على سالب 9.8 معناته أنا أقول تحت سالب، فمعناته
الديستنس بيطلع بالسالب، ليش خطأ؟
لأنه هنا أنا أستخدم الماجنتيودز فقط. But I want to answer you why. So give me a second. Yeah, here I'm just dealing with magnitudes.
اوكي
Yeah. Okay, D. Find the components of its velocity when it is at a height of 19 meters. So now it's opposite. بدل ما نحن عندنا distance أو time، نحن عندنا الحين distance 19 meter height ونبغى velocity. زين. كيف نسوي؟ نحن نعرف أنه أقصى ارتفاع هو 29.4. ليش هذا ما جالس يطلع؟ نحن نعرف أنه أقصى ارتفاع هو 29.4 meters. زين. الحين هو يقول على ارتفاع 19 متر what is the velocity. بما أنه أقصى ارتفاع 29.4 معناته نحن نروح نوصل 19 متر مرتين، مرة في الصعود ومرة في النزول. صحيح؟
صحيح.
جميل. Which means we need to find the time أول. Okay. How do we do that? Well, again, our three equations: V equals U plus AT, S equals UT plus half AT squared, V squared equals U squared plus 2AS. And our only rule is we want when Y equals 19 meters. So let's do it. I will use equation 2. 19 meters equals 24 T plus half minus 9.8 T squared. معناته minus 9.8 على 2t squared minus 24t لا plus 24t minus 19 equals 0. أيوة في حد كلم؟
I have a question.
أيوة.
You used the second equation.
أيوة.
In U, why did you write 24?
Isn't the y component of thingy 24? Or was that the x component?
Oh, isn't it supposed to be the final velocity? Or,
No. 30 sine 53, 30 v sine theta is my y component, so I'm just substituting that. Now that gives me a quadratic equation with t squared. If I solve this quadratic equation, it will give me 2 times possible. 1 second and 3.8 seconds. Which makes sense. At 1 second, it's going up. At 3.8 seconds, it's coming back down again. But it still hasn't answered our question. What is the velocity? Well, now that we have time, all I need to do is put it in v equals u plus at 2 times. مرة أحط t 1 second ومرة أحط t 3.8 seconds. And I end up with these values. At vy1, at time 1, my y is 14 meters per second. And at y2, my speed is minus 14 meters per second. Which makes sense because it needs to be the same number, but in opposite directions, since one time it's going up, one time it's coming down. So far, so good. Any questions?
No, Doctor. Thank you.
Okay. Seeing none. Somebody asked me about circles at the beginning of this chapter, at the beginning of this lecture. He said, what about if we're going in a circle? When we look at circular motion, there are 2 types. Take a quick look at this screen and tell me what are the differences between the two motions. Can you tell me what's the difference between the
One
two?
is constant.
The
and
second
other-
is faster than the first.
Okay, that's true.
Not constant velocity.
Button.
The one on the left keeps moving at all times with the same speed, at the same rate. كمل مروحة. The first one stops, speeds up, slows down, stops. Now these 2 types of circular motion are rather different. The first one is what we call a uniform motion. The second one is what we call a non-uniform circular motion. Today, or in this chapter, in this course, we're going to look at uniform circular motion. Non-uniform, we're not going to look at it. Remember in the PIQ we did in the previous lecture where we're looking at the directions of the velocities when something was going in a circle?
Yes.
Does anyone remember what will be the directions here for 1, 2, 3, and 4?
Tangent line.
It will be tangential. So if I am assuming this circle is going clockwise, then my velocity is going to be tangential at all times. Okay. So the direction changes, but it always remains tangential to the circular path. Now here's an interesting thing. This thing moves at a constant speed, صحيح?
صحيح.
Okay.
Yes.
But it changes its direction all the time. Because it's going on a circle, so V changes direction every single moment, صح?
So.
And what did we define acceleration?
Inside.
Okay, inside. But what was the definition of acceleration? مش حال الcircle in general when we defined acceleration back in chapter 2. وإيش كان تعريف acceleration?
The rate of the change velocity.
Or the magnitude.
So acceleration was the rate of change of velocity, right?
Yes.
Velocity, not speed. And this is a very, very important distinction. Velocity and not speed. Why is that important? Because even though the speed of something going in a circle is not changing, it's fixed in uniform circular motion, we still say it undergoes acceleration because the direction changes all the time. And if the direction changes, then your velocity changed. How crazy does this sound? Okay. So this acceleration that is changing it causing the velocity to change every single moment, we call it centripetal acceleration. Okay. The velocity vector is always tangential, and the acceleration vector is always towards the center. And this is what we call centripetal acceleration. Careful, not centrifugal acceleration. Centrifugal is actually something else. It's a fictitious force, which I'm going to tell you about in a bit. It's non-examinable. It's not in your syllabus, but I'm going to tell you a bit about it. Actually, maybe it isn't your syllabus. I need to double check. So the magnitude of the centripetal acceleration is acceleration equals v squared over r. The smaller the circle, the greater the centripetal acceleration, or otherwise known as, to turn at a large speed, you need a large centripetal acceleration. So if you have something and you're trying to make it go and round around your head, for example, you either need to move it very fast or use a very, very short rope. And this is a to-do at-home experiment if you have time. Just take a tiny, tiny piece of string or, a bit of rope, tie it to a bucket, or a string, tie it to a rock or something, a stone, okay? And try just moving it around, okay, in circles. See what happens. Play around with different sizes of string and see what happens. Okay. So this is the end of today's lecture. It's 1:21. And I think we will keep frequency, time period, and relative motion for the beginning of next lecture. You have any questions?